In this video, I will talk about, or I will give you the idea how to plot the stars luminosity and the temperature, or what you call as the absolute magnitude and the color on a graph. And that graph we call as a HR diagram or HR graph here, or we call a Hertzsprung-Russell diagram, also known as the HR diagram. Again, the HR diagram is simply a plot of a star's temperature and the luminosity, or the color and the absolute magnitude. The color of the star is directly linked with the temperature of the star. So if we know the color, then we can tell about the temperature of the stars, or if we know the temperature, then it should have a particular color, or it emits the more light at a particular wavelength or at a particular color. The absolute magnitude, so you might have already watched other videos, my videos about the absolute magnitude and the apparent magnitude. We call it apparent magnitude. So let me give you a little bit background about these two, apparent magnitude and the absolute magnitude. So the apparent magnitude is how bright a star looks when it is looked from your eye or through a telescope from Earth. So for example, if you compare Sun and Betelgeuse, then the Sun looks much more bright to our eye than the Betelgeuse star. And the reason is the star, the Betelgeuse, is a lot very far from us, very far from the Earth. So let's say this is our Earth surface here, Earth, and the Sun is here, and the Betelgeuse is much farther here. It's a lot farther than to us. If we are right here at the Earth surface, let's say here, I'll just make it a different color. Now let's say you are here, right here, standing. As Sun is much closer to us, then it looks much more brighter compared to this Betelgeuse. But in fact, this one is emitting a lot of energy. It is emitting a lot of energy per unit time compared to the Sun. That means it is much more brighter. If we, let's say, if you get a chance by some way, that's not possible, but if we just visit the star, this star, then the Betelgeuse would appear much more brighter compared to the Sun. But because we are at the Earth surface and the Sun is much closer to us than the Betelgeuse, the Sun appears a lot brighter. So that is called the apparent magnitude. The apparent magnitude of a star is how brighter it looks to us when we see or when we view from the Earth's surface. So that is called apparent magnitude. The higher the apparent magnitude, what does this mean? The higher the value of apparent magnitude means the smaller bright it looks to us. Okay, the smaller bright it looks to us. So for example, let me give an example here. Let me erase this here. And then I will talk about the absolute magnitude. Let's say, for example, the apparent magnitude of a star is, let's call that is an M1 star, is 5. This is the symbol for apparent magnitude. And the other star has 30 value. Which star appears more brighter to us. So as this value is smaller than the M2 star, this star would appear much more brighter than this star. In fact, this star, M1 star, is about 10 billion times more, or it appears more brighter to us than this star, M2 star. So the apparent magnitude gives us the information how bright it looks to us. Now let's go back to the sun and the Betelgeuse. Let me erase this one. So if we look at the value of apparent magnitude of the sun, the apparent magnitude of sun is minus 26. Again, I'm talking about apparent magnitude. Apparent magnitude. So this value for the sun, the value is minus 26.72. And if you look at the same value of the Betelgeuse, for the Betelgeuse, this value is 0.5, about 0.5. So if you look through a telescope, or if you look through our eye, then the sun is way, again, it appears that the sun is much more brighter than the Betelgeuse. But now let's think, or let's write down the values of the sun and the Betelgeuse, the absolute magnitude of the absolute magnitude. So the absolute magnitude of the sun is about 4.5, and of the Betelgeuse, this value is minus 7.2. So what does this mean? That means if we look both sun and this Betelgeuse from the same, if they are at the same distance, then the Betelgeuse would appear much more brighter than the sun. Or if you do the math, then the Betelgeuse is about 63,000 times brighter than the sun. That means it is 63,000 times more luminous than the sun. Okay, so what is the absolute magnitude? So I'm not writing all the details of the apparent magnitude and the absolute magnitude, because I already have discussed about these two in other videos. So feel free to go back and watch the other videos. So what is the absolute magnitude again? The absolute magnitude means how brighter the stars. Let's say this is again the Earth's surface, and if you keep all the stars exactly at the same distance, and this distance is the 10 parsec, or in other words, this is equivalent to 32.6 light year. So if we have kept all the stars exactly at the same distance, then the star which appears more brighter to us would be the absolute magnitude. So which star would appear more brighter? The star which emits more energy would have the more brighter. So absolute magnitude in fact tells you the luminosity of the star. So the idea of the absolute magnitude is it gives you the luminosity. It directly relates the luminosity of the star. Okay, so you got the idea about the first question here. What is the meaning of absolute magnitude of the star? So write down the details of it. Okay, just go and watch other videos, or even from this video you should be able to answer this question here. Okay, so now the most important part comes here, is plot a graph of the color and the absolute magnitude here. So I'm not going to do for all the stars, and as an example I'll show you only few of them, and the rest you have to do it by yourself. So on this scale, on x-axis we have the color here. So this is the color and this is the absolute magnitude. so which we denote by capital M. So let's say, for example, Adhara star. So this is a star here. What is the color? The color is bluish white, and the absolute magnitude is 1.50. So how are we going to plot it? So let's look at here, bluish white. So here I have bluish white, and the absolute magnitude was 1.50. So this is 0. If we go above, then it will be negative. So this is 5. Okay, so 1.5 should be somewhere here. So that is, so now look at this number here. So this corresponds to about 1.5 here, and the color is the blue white. Okay, so this one is 1.5, and this is the color is 1.5. So now the same thing you have to do for the other stars, and I'm going to choose another star. Now let's call sun. So look at the number here for the sun. The sun is yellow white. So look at the sun, yellow white, and the number is 4.8. So how are we going to plot it? 4.8 and the yellow white. So let's look at yellow white here. So this is the yellow white, and the 4.5, which is close to 5, should be here. Okay, let's do one more. I'm going to do with the, let's say, Mira. Let's say the Mira here. So this one is the red and is 0.99. The red and 0.99. So close to 1. So it should be somewhere here. The red. Or if we do one more, let's say Capella. The Capella is again yellow white. So yellow white. So if you look at the Capella, it is yellow white and -1. So yellow white and the -1 has to be somewhere here. So that way we plot all the stars in this diagram here, and this plot is called HR diagram. So okay, so you have to do for this part, you have to plot the graph for all the stars. Okay, if possible, just write down the name as well. So for example, this one was Capella. Okay, and so if possible, just write down. So now what it's asking here, what is the correlation between the absolute magnitude and the luminosity of a star? So as I mentioned earlier, the absolute magnitude of a star is directly proportional to the luminosity of the star. So that means, so smaller the absolute magnitude is, greater is the luminosity. And plus more negative, this is again the answer for number 3 here, but you have to write down in your own words. More negative the absolute magnitude is, the more will be the luminosity of the star. Okay, more negative means the greater is the luminosity of the stars. Okay, so we got this part done. So now what is the other part here? The correlation between the color and the temperature. So what is the correlation here? So the more the blue means this star is more hotter. This is a hot star. So this is I wanted to use a black color here. So this means more hot, and this is comparatively cold star. Okay, so the temperature this way, if you go along x-axis, temperature decreases. Okay, the blue color means hot stars. If you look in the night sky and the star which appears more blue, that means it is the more, it has more temperature, and the rest red stars it means it is cold star, comparatively a smaller temperature, the surface temperature of the stars. So along this way, orange, now let's say if I compare orange and the red, then the orange is more hot than the red. But if I compare the blue and the orange, then blue is more hot than the orange stars. So the color of the stars tells you the temperature. How come it does tell you? You have to watch my other videos. Now already answered these questions here, which stars are hotter or red. So you should be able to answer these two questions. Now the important part is, so you have to now identify the stars into these four categories: the main sequence, white dwarf, supergiant, and giant. So if you plot all the graphs, if you plot all the graphs here of all the stars on this HR diagram, then it should look like this. Let me draw a graph here. So it should look like this here. So you will see mostly the stars having most of the stars would fall here, and there would be few stars here and few stars here. So this is how the distribution would look like. So the star which falls in this region here, in this region, so this is called the main sequence. The main sequence here, main sequence star, main sequence stars, and I will talk about this one. And the stars which lies here, and we will have in fact two of them here. So this star is called supergiant star, and this star, the star which lies here close to the main sequence and above, is called giant star. And there will be another region here, this star, the stars which lie in this region of the HR diagram is called white dwarf. The white dwarf. So once you have plotted the graphs, just look at the stars, or you can also tell in fact from the absolute magnitude and the color. So white dwarf, now let's say for example the white dwarf has, the color would be blue and white, but the magnitude or the luminosity would be higher. Higher means the absolute magnitude would be higher. That means the luminosity would be smaller. So if I look at this way here, in fact the luminosity increases. So if I go along this axis, that means the luminosity increases. That means it radiates more energy. Okay. So the star which lies here is called the white dwarf. The star which lies on this line or in this region is called the main sequence. The star which lies in this region is called supergiant, and this is called the giant stars. And the name itself tells you all the stories here. The supergiant, that means the radius or the size of the stars are massive. That's the reason it is called supergiant. The giant stars are much bigger than the main sequence stars, but smaller than the supergiant stars. The white dwarf, this white dwarf stars are much smaller in size than the main sequence stars. But again, this is a massive star. If the mass is there, it does have a very high density. Okay, the white dwarf stars, the white dwarf has almost lost its life. There's not much fuel left. So almost it has burned its fuel. So only few energy are left there. So the size is small, but it is a dense star. Okay, so based on this one, you should be identify, or at least you have to name one main sequence star, So for example, the sun, you would see it is the main sequence. And then you have to write down the name of the white dwarf, supergiant, and the giant stars. Okay. Now, which star has greater radius, white dwarf or main sequence? Okay, so if you look at this is the main sequence star here, and this is the white dwarf star here. So the radius of the main sequence star is much greater than the white dwarf star. If you look at the mass of the sun and the white dwarf, it should be about the same size of the white dwarf and the main sequence star. But the radius of the sun is much more greater than the white dwarf. Okay. So next part now. Which stars have lost their fuel? You already know the answer, the white dwarf. They are almost at the end of their life. They are almost burned their energy. Okay, so from that information, you should be able to identify the blue-white star within this range of absolute magnitude would be the white dwarf, or the blue-white, or close to white, or the blue star within this region would be the white dwarf. And the other question is, where are most of the stars located? So if you plot the graph here, the most of the stars fall within this region here, that is the main sequence star. The main sequence star means they are burning their fuel. That means the process by which it radiates energy, that is called the nuclear fusion. So through the nuclear fusion, the stars are generating energy. So for the main sequence stars, these stars is still burning their energy, or converting the hydrogen into the helium. So that is called the nuclear fusion process. So most of the stars lie under this main sequence stars. So now the last question is relationship between the mass and the luminosity of the main sequence star. So I'll just plot a graph here, and the graph should be self-explanatory. So let's say, let me use a different color here. So I'll just use a different color. Or in other words, I can answer here. So if you go along this way, then the mass increases. Okay, so each one will have a smaller mass, and here it will have a bigger mass. Okay, so what the question is asking here is relationship between mass and the luminosity. So that means the higher the luminosity is, this absolute magnitude, then more negative means the smaller, the more negative absolute magnitude means the more is the luminosity. So higher the luminosity means the higher the mass is, because it has a higher surface area, or it also tells you the size of the star. So there is a directly relation. So that means more luminous means the more massive the star is in size, and this is for the main sequence star. So this is it from this video. If you have any questions, anything you do not know about this, please write to me. Thank you so much. Please do not forget to like, share, and subscribe the channel.